We're going one by one. Let me open it up to you. Drop some knowledge on everyone. Show off a little. Any of those we're going to do today that you know already? I hope so. Thomas? Oh, that okay. Some people don't know that one, but what is a parallelogram? Yes, but it doesn't really have a length and a width. A width. We call it a base and a height. Yes. So for parallelogram, base and height. Yep. You think you got another one there, Mason?
Oh yeah. Triangle. 1/2 base.
Yes, 1/2 base and height. Some of you may do base height divided by 2, whatever floats your boat. Come on, there's got to be at least one more up here. I'm going to say 2 more. Hi, Remy. Length times width for your old rectangle. Some may say base times height too. Yep. I thought you would know the circle, Caleb, or you're going to go big time. What? Thank you. Pi r squared. What's that r in your pi r squared there, Caleb? Radius length, yep. Anybody know the old trapezoid? Or maybe a part of it? Anybody remember traps? Okay, trapezoid. 1/2. Every trapezoid has a height, which we multiply 1/2 by. And then ready, we multiply that by, remember a trapezoid has 2 bases that are parallel. You add those together. B1 and B2, B for base. So B is the base length. The old rhombus and kite, same formula. Not expecting you know this at all. Ready? 1/2. Ooh, ready? D1, D2. I'm going to force you guys to think about what the D represents there. It is the part of a rhombus and a kite that they both have that starts with D. A? Diagonal length, yes. Gets me fired up. Are they ever congruent? Think about your properties. Rhombus, kite, are they ever congruent? No, so you should always have 2 different numbers here. Oh, for a bonus, what quadrilateral are they congruent? The diagonals. Square, okay, that's an easy one. Way to go. Rectangle, diagonals are congruent, not in a rhombus or a kite. All good? All right, have those calculators fired up. What, Caleb? What happened? What did I do? Oh, okay, you got me there. Isosceles. Look at Mr. Rico Suave back there. Yes, and isosceles trapezoid. I was thinking more of the parallelogram family, but I did not specify that, so you got me there. It's only going to happen today, and that's it. Never again for the rest of the year. So good try. All right, here we go. Parallelogram, perimeter and area. Find both. Perimeter and area. Okay, guys, it's not of the whole thing. It's just everyone see the parallelogram in your diagram. All right, perimeter, all sides added up. Hey, I only gave you one side as 23. What about the other 3 sides? It's a parallelogram. Parallelogram property that I can use here. Opposite sides. Opposite sides. Congruent. So if one side's 23, so is the opposite side. What about the other 2 sides, though? Hi, Claudia. I can do Pythag. Nice. You want to get out what I can have write it down for me. 24 squared plus 7 squared will give me the other side. Nice. When you're ready with that other side, let me know. 27. Yes. 25, which means the 4th side is also 25. You guys are good. My perimeter here Oh, I forgot this. 86? No. 96? Okay. I have yet to do it this year, but I'm going to start this unit. Yes, you will get points taken off if you don't provide units. And you'll see why when we do the area. So this is 96 feet. We have any issues here? We good? Writing it down. We're good. Okay, ready for the area. Base times height. Guys, the base and the height are already on that diagram. You just got to know which one is which. That's my point I'm going to drive home to you today. Base times height. All right. Ready. The height always comes from a vertex and is perpendicular to the opposite side. Do you see a line segment up there that's been drawn in for you that starts at one vertex of the parallelogram and is perpendicular to the opposite side? Name the length of that segment. 11. 20. Where's the right angle here? So what is it? Not 23, but it's the 24. Everyone see that? Starts at a vertex, perpendicular to the opposite side. So the height's 24, and the height is always drawn to the base, and the base better be on the actual figure. Like, nobody should be giving me 7 here. 7's not part of the parallelogram. The base should be a side of the figure. So what do you want to give me instead? 20. 23. Any issues there? Base and height. Height's always perpendicular, and it's drawn to the base. And the base has to be a side length. So go ahead, crunch those for me. What do you got? 30. Yeah, good job. 11. 552. And this is why I need to start seeing units, because it's not feet anymore. Feet squared. Square feet, however you pronounce it. That's why we need units now. How's that look, Jack? Great. Anybody else want to comment? Anything else here, Caleb? Or are we good? Okay. Just want to run it by the old master back there, the old sensei. Questions? All right. Oh, yeah. A little review time. Find the area. Everyone see the height in this diagram? Yet to be labeled. We'll find it in a second, but we can at least fill in the base. Height's drawn to the base. What is the base length of this parallelogram? 117. Hey, take a look. It's drawn to this base. It's not labeled, but Matt says opposite sides are congruent in a parallelogram. So that's how we knew the base was 17. How are we going to find that height? We're going to remember our 45-45 rules, right? The 9 is across from what degree measure? Remember, I have a 45, I have a 90, so the other one has to be 45. So it's across from 45. What am I looking for? The side also across from the 45. What do we know about those sides? They're equal, so how about the height here? Should be 9. The sides across from the 45s are always equal. And then the area with proper units for me. Oh boy, 23 area with proper units. Garbage. 25.
153 yards squared.
All good. Okay, you guys are trucking here. Ooh, uh-oh, now it's a 30. Okay, how about the base? 18, what do you got for the base here? 32? Got to find the height now, though. Got to find this height. Everyone see the 30, 60, 90? Oh, it's been so long since we did this. Well, what's the 12 across from? What angle is the 12 across from? 30. What angle is your height across from? 60. Ooh, how'd I go there? Anybody digging deep for the rules there? You think you remember there, stud? Oh, boy. 2x, ready? Okay, that's part of it, but that finds the side across from 90. There we go. Multiply by radical 3. So what am I going to put in for my height then? 15. 60. Come on, Henrik. One job back there. Good. You're getting nervous. And it does say round to the nearest tenth if necessary. Oh, it's necessary. It's necessary. $22. What do you have for me, nearest tenth? Come on. We're better than this. Thank you. Yeah, a little review here. 30-60, 45-45, Pythagorean theorem. It does not end. Everyone have a good weekend. Good to hear. What'd you guys do? Oh, sounds exciting. All right, moving on. What's your deal over here? I got like the 3 Goof Troop or the 3 Stooges. I don't know which one's a better name for that. This trio over here. I'll go with Goof Troop. Okay, A. Shaded triangle now. Shaded. Not the whole thing, not the dotted one. The shaded triangle. Perimeter first. Guys, how many sides are you given in that shaded one to find the perimeter? How many sides out of the 3? 2 sides. Yep. Got the 2 sides. You got 19 and you got 41. What about the third side, though? Is there any way you could find the third side so I can add it to find the perimeter? 7. Great job. Pound it. 26. Let's hear it, Jack. What am I going to use to find that third side? There you go. That's not a nice number. I know. Sorry. Welcome to above average math here. Not a nice number. And there's no rounding directions either. So we're going to write out the full calculator display at the end. I would probably just leave this underneath the radical and then add it to 19 and 41 and then leave the full calculator display there. So square root of 16, 1,629. And hopefully, what do we have? 100.3608.721 inches. And the area, you shouldn't have to find any numbers here. Area's already there. So can you guys pick off the height and the base? Remember, hey, whoa, stop. It's not base times height anymore. 1/2, yep. Make sure we can just transition there. We're not doing a parallelogram. Okay, what's the base and the height? Can you get that? Remember, height, perpendicular line drawn from a vertice, base is on the actual triangle. What do you got for me? What do you think? Oh, 20. Height, okay, let's go height first. 30, beautiful. And base on the actual triangle, 19, nice. Issues there? I just don't want you guys to pick random numbers off. So what are we looking at? 285 square inches. All right, I'm going totally hands-off on part B and walking around and helping you out. Okay, if you want to talk to somebody in your group, it might be helpful. Okay, this is no joke on this one here. Take your time. Write out the full calculator display for your answers. Find the perimeter of the shaded region and then the area. Okay, I'm getting the perimeter be 71 and change there. Both Pythagorean theorems I use are up top here. Okay, this is what I use to find b squared here. And this is what I use to find the hypotenuse of the shaded region right here. Okay. Before I get to the area, anything about the perimeter? If you did 6 squared plus 13 squared, please realize the 13 is the hypotenuse in that unshaded triangle. All right, real quickly, the shaded triangle is what type? It's a right triangle. Anybody know base and height of a right triangle? Another name for them. Another name for the base and the height. 2 legs. 2 legs. So in this case, the 2 legs are 29, and what'd you find in the previous part? Square root of 133. Yep. So that's what goes in for the area. So writing out the full calculator display, 167.2221576, and we're going centimeters squared. Yep. Anything on the Pythags especially? We okay handle that? Because that's probably at the level I need you at right there as far as finding area and perimeter. You ready for DeAndre? All right, he's a landscaper. All right, he is a landscaper. He wants to throw some mulch on his old triangular garden. And he knows that 1 bag of mulch covers 12 square feet. How many bags is he going to need? Well, we've been doing perimeter, we've been doing area. We've been doing perimeter, we've been doing area. Which one do I bust out here? Look at the units. Square feet. Tells me automatically I'm going to find the what of the triangle? Area, yeah. And this is a triangle, so I'm going to use 1/2 base times height. All values are already given. No Pythagorean theorem needed here. They're already given. So I need somebody to pick the base and the height off this triangle. Base and height. Oh, 5. What do you got for me? Base and height of his garden. 9 for the height. Drawn to a base of what on the garden? 7. There we go. So the area is going to be, what, 31.5 square feet. And here's where I'm going to have a lot of you get confused here. And I need to get you over this hurdle. Do I take the 12 and multiply, or do I divide it by 12? Okay, let's think about this. How many feet does a 1 bag cover? 12. You have how many feet? So I get 12 feet. There's 1 bag. 24. There's 2. See where we're going here? Do I want to multiply or divide by that 12? I want to divide by the 12 for the number of bags. So I take the 31.5 and I divide by 12. Now here's where the common sense radar has to go off. Everyone ready? Let me just real life here now, okay? Because I don't know if anybody's ever been to Lowe's or Home Depot or Hewitt's or whatever stores sell mulch. Let me put you in a little scenario right now. I walk in, whoever is the person helping me, and I go, yes, can you please help me? I need 2.625 bags of mulch. They're going to laugh at me, okay? You're an embarrassment, more than you already are, okay? I cannot have partial bags of mulch or of anything, all right? So how many total bags are going to get the job done? 3 bags. That will not be in the directions either. It won't say, hint, hey, folks, round to the nearest whole bag. We're going to have to know I can't roll into Lowe's or Home Depot or Hewitt's and say, can I have 0.625 of a bag? All right. We all good? Self-respect. That's what they'll say back to you. This guy's unbelievable. Now he's going to pave. All right. He's going to throw some stones around. So I don't need the area anymore. If I'm talking about the border, I'm talking about the perimeter. Yeah. So this is going to be perimeter here. I'm going to border it with some stones. It's going to look like a masterpiece at the end. I got 23, right? Look, I gave you guys everything. This is easy. And you're like, boom, 45. Just like we did last problem, I'll divide it by 4. We're good to go. No, you won't. I laugh now, but you will see this unit and next, where I switch the units mid-problem, excuse me. All right, I'm going to switch the units mid-problem. Got to recognize it. Because what's the 45 in right now? Feet. And each stone covers 4 inches. Inches. I'm not going to bold it. I'm not going to highlight it. I'm not going to bring your attention to it. We just got to see that. All right, so if this is in inches, I need to convert this feet into inches. Suggestions on how to do that. Multiply it by 12. So how many inches are in his garden? Woo, boy, 540 inches. Then define the number of stones. Then I take the 540 and divide it by 4. He's going to need a lot. He's going to need a lot of stones. 135 of them. Hopefully he's got a big truck or some big commercial vehicle. Questions from you guys? We all good? Because I'm going to go slightly different to end the class. Have you ever talked about this concept in any of your science, maybe even social studies classes? Population density? If something has a high population density, that means it's kind of a small area with a ton of people packed in. Okay, like if I start bringing in everybody from the hallway, classes next door into this room, it's going to have a high population density. But if I just take you guys and go down the auditorium, it's going to be pretty low because the auditorium's a huge space with not many people. So that I know you understand this concept. There are 50 states in the United States, FYI. Guesses on which one has the highest population density. And people hear this and all of a sudden they just give me the biggest state. That doesn't know how it works. It depends on how many people are there. Okay, I got Maddie says Rhode Island, he thinks is number 1 on the list. Thomas. California, okay, big state. I don't know how many people, but New York, why not, right? The city's pretty packed, not a big area. All right, so I got some already. We'll figure it out in a second. Anybody else? Nominations for top state, highest population. Vermont, it's a small state. I don't know how many people. Michigan. Florida, okay. All right, let's go on the opposite end. Low population density. Okay, here we go. I will let you know nobody guessed the greatest population dense state. You did guess the lowest one though. The highest state with the highest population density would be New Jersey. Rhode Island was number 2, followed by Massachusetts, Connecticut, Maryland, basically the New England states. Florida was in there. Somebody guessed Florida at 8. The lowest one, yes, you guys, most of you were correct in saying Alaska. Wyoming was second to last, yes. Okay. So everyone understand the concept of this population density, when it's high versus when it's low. New Jersey, decent sized state, but as you can see, it's got almost 9 million people in it. Okay, it's got almost 9 million versus Alaska, which only has under 1 million people. Okay, but huge land area, almost 500,000 square miles. So, okay, so let's not do states now. Let's go to the boroughs of New York City and figure out which one has the highest versus which one has the lowest population density. How do I actually calculate that number? I take the population and divide it by the land area. So I'm going to take the population of each borough, divide it by its land area, and I'm going to compare the 5 at the end to find the highest and the lowest. So go right ahead. I'll give you a minute to do that. Again, population density, population divided by the land area.